it's kind of a unification of biological physics across so many different types of organisms: fungi, plants, vessels, brains, coral. All of them have the same principle, right? Physical networks are embedded in 3D space, and all of these physical networks are constrained by 3D geometry, right? They're constrained by thickness. How much room do I have to move in the brain, in the body? In recent times, we've done incredible work mapping out the 3D morphology of biological networks. This right here is a neuron from the Human Connectome project. They've mapped out a human neuron. The new paper introduces the fact that maybe if we minimize surface area, then we can replicate biological networks. And what's really cool is they introduce an exact mathematical mapping between this local network design of minimizing surface area and the high dimensional Feynman diagrams that we see in string theory. Okay?
Yes.
That's the key insight. This is the MinSurf network. It was implemented in Mathematica. This is the new code that they use with finite element methods to solve for surface variation problems. They actually have it available on GitHub, so you can use it.
Yes.
And what they really did was they inputted the connectivity of real maps, and then they said, okay, they asked the algorithm to generate the optimal surface geometry. So it makes up a bunch of meshes, of polygonal meshes, and then tries to figure out what the optimal surface geometry is such that it minimizes surface area, and they could reproduce what the biological networks were doing. There are a bunch of really cool applications that I just want to go over. One of them is 3D bioprinting. So what you can do is design scaffolds using this algorithm to create physically correct microvasculature if you want to create an artificial tissue and you want to improve blood flow in medicine, right?
So now we basically have a pathway to 3D print things that can be integrated into our system.
Exactly.
That would map structurally more onto the way our biological system exists to optimize for the potential for the body rejecting it and all these other
Exactly.
things.
And the body not having to work harder than it should to push blood through this artificial system.
Yes.
Right?
Yes.
Another one could be hardware design. Like if you want to use these surface optimization principles to make 3D chip architectures, right?
Yes.
Like neuromorphic chips, you can now use these principles to do that.
Yes.